All right, everybody. So for 8.4 and circles, we're going to go into just the basics. Math 3 goes a little bit more in detail, but I'm going to talk to you, okay, what is the equation of a circle and how do you graph from that? The equation of a circle, though, is based on a couple of things. The first is the definition of a circle. The definition of a circle is simply that it's not just a round shape, but it's all the points that are equidistant from the middle point. That's why a circle has a center and a radius. If this is our center, if the radius is a certain distance, the circle then is all the points that are that same distance away. So this way, this way, this way. All those distances should be the same. That's what makes it a circle instead of an ellipse or something else. Yeah, I know. It's good enough. If I want to make a more precise circle, the way I would do that is, there's a couple ways, but one way is to take a piece of string of a certain length, tie your pen to it, hold the string in the center, and then spin it around. As long as that string stays the same distance, you'll get a circle. Because that string distance is your radius. For us, then, we're going to take that definition that the radius is the distance from the center to the circle. All the points on the circle are that same distance away. And use that to come up with an equation using the distance formula. So the distance formula that's in here, the actual Math 3 class typically does a lot more with deriving this, working through why it's this way. For you guys, we're just going to practice using the formula. But here, the distance formula, square root of x2 minus x1 equals, or sorry, plus y2 minus y1 squared. I said that. The distance is equal to the square root of the difference of the x's, x2 minus x1 squared, plus the difference of the y's, y2 minus y1 squared. If I set that equal to the radius, I can come up with all the points that are that same distance away from that center point. So this right here is the formula we're going to be using all today. X minus h squared plus y minus k squared equals r squared. So if you get nothing else down here from the notes, you need that equation right there. Now, a couple quick things here. Actually, no, we'll come back to those. Does everyone notice that there's no square root in our actual formula for the circle, whereas there was up here in the distance formula? The reason that square root's not there is that they've squared both sides. And in fact, you could actually think of this as the Pythagorean theorem. A squared plus b squared equals c squared, where a is the x distance of a triangle, b is the y distance of a triangle, and c is the radius. You do that as well. There's several ways you can come up with this equation, but what we're going to do is use this equation knowing that h and k are our shifts again, like they have been for every other unit where we've graphed. H being shifting left and right, the x shift, k being the up and down shift, the y shift. But in this case, the important thing is to know that circles would normally be about 0, 0. That would be the center point, unless it's shifted. And so if it's shifted, the center of the circle is going to be HK. So put that down on your notes. The center of the circle is HK. And then the radius is R. Actually, it's already written on your notes, but right there. Highlight it, rewrite it, make sure you've got it there. So now this actually gets, you could get very, very complicated with this, but we're not going to. We're going to keep the simplest way of graphing these. So for this first example, x squared plus y squared equals 25. If I'm going to graph this, yes. So if there's no h or k, the center is 0. So 0, 0. Go ahead and write that down. Center. Center is 0, 0. radius. The radius comes from 25, but we have to take the square root. So this is going to be the square root of 25. Sometimes that's going to work out really nicely, like this one. Square root of 25 is just 5. Now the trick is to graph this, we could find a whole bunch of different points, but it's actually really hard to find a lot of them. There's only a few that work out really nicely. Here's the fastest way to graph a circle. Find your center point, and then take your radius. Go right the radius distance. So in this case, let's use a different color here. I'm going to go right 5. 1, 2, 3, 4, 5, and put a point right there. I'm going to go left 5. 1, 2, 3, 4, 5. Put a point there. I'm going to go up 5. And I'm going to go down 5. Always from that center point. Those are kind of 4, well, those are 4 points on my circle. And so if I have those 4 points, I can draw my circle through those 4 points. It's not going to be perfect. This isn't an art class, but just get as close as you can to those 4 points and something that looks kind of like a circle. Once you've done that, you're finished. Now, we could find other points. So if I actually use the formula, I could find that if I put in 3 squared plus something squared equals 25, oh, the something squared would have to be 4. So I should have a point at 3, 4, right there. I should have a point at 3, -4, like down here. But again, my circle's close to those, but not quite on them. Should have been a little bit wider, but we don't need to be that precise when we're graphing these circles. As long as the edges, the left, right, and top, bottom edges are in the right spot, and it's a circle shape, that's going to be good enough for this class and for next year. Does that make sense to everybody? See a lot of you copying it down, doing okay, but I'm not getting a whole lot of response. So we're doing all right. It's going all right. The other classes are all reviewing for their test. You guys have your test next week, so we've got a little bit different pace. So here, letter B. So for letter B, x plus 2 squared plus y squared equals 18. The center point. This is where we start to have issues. The center, hk, remember that the formula was minus h and minus k? So the center here is actually going to be -2, 0. It's the opposite of what's in the parentheses. -2, 0. So I can find that point. -2, 0 is right here. -2, 0. Then I need a radius. So the radius is the square root of 18. Well, that doesn't have a nice answer. We could reduce it. We could say the square root of 9, or square root of 18 is 9 times 2, 9 is 3 times 3. So you can take a 3 out, make it 3 root 2. Yeah. So we're going to take the opposite of this one. That's going to be our x coordinate. So -2 instead of +2. There's nothing over here, so it's still just 0. Just like the last one was 0, 0, because there weren't points for either one. Good questions. So now I got this. This actually doesn't help me graph very much. So even though this is the reduced form, let's use a calculator and get an approximation. Tell me what, using a calculator, what's the square root of 18? And grab a calculator. What's the square root of 18? 4.2 something, 4.24, somewhere in there. So then when I graph this, I can't really tell where 4.24 is, but I know that it's more than 4 and less than 5. Does that make sense to everybody? So what I'm going to do is graph from my point here at -2, 0, I'm going to count right 1, 2, 3, 4, and a little bit. I'm just going to go a little bit past 2. Up 1, 2, 3, 4, and a little bit. Left 1, 2, 3, 4, and a little bit. And down 1, 2, 3, 4, and a little bit. Connect those dots. And that will be our circle. That's not bad. Every once in a while, I get one that looks at least somewhat circle-like. But again, don't worry about it. As long as it's the right points and the right general shape, it's going to be fine. As long as you're not drawing squares or diamonds, you'll be okay. How are we doing with that one? Maybe getting there. So go to C. Here's where we've got the whole thing finally. So the center point. The center here would be +1, -3. Is everybody good with that? +1, -3. Opposite of the two things in the parentheses. So +1, -1, 2, 3. There's our center point. Our radius is going to be the square root of 50. Again, if I simplified that, I'd take the 50 and break it apart. Everybody remembers doing the factor tree. 25 times 2, 5 times 5. Here's a pair of 5s. So I could write this as 5√2. But again, to actually graph this, it's going to be better to take the approximation. So go ahead, use a calculator. What's the square root of 50? 7.07. So like 7.1, just a little bit more than 7. So I'm going to go from my center, right 1, 2, 3, 4, 5, 6, 7, and a little bit. Left 1, 2, 3, 4, 5, 6, 7, and a little bit. Up 1, 2, 3, 4, 5, 6, 7, and a little bit. And down 1, 2, 3, 4, 5, 6, 7, and a little bit. Does everybody get the pattern here? Find the center, find the radius, go left, right, up, down, and then draw on your circle. That's not so good. Let's try that again. Again, they don't have to be great. They're going to probably be lumpy. They'll have something on the wrong side. They'll have a side that's not the same as the others. But get those points. Get the rough shape of a circle. That's going to be enough. Did I not do 7? Remember, you're going from this point. 0, 1, 2, 3, 4, 5, 6, 7, a little bit. Because remember, we're at 1 already. This one. From 1, 1, 2, 3, 4, 5, 6, 7, a little bit, right? Because we're at 1 already. And so we're going from that point. So none of these points are actually at 7. Does that make sense? No, I appreciate you asking and double checking to make sure we're all on the same page. So those are good. I'm going to show you one more. We're not going to do a ton of these, but I want you to see what it looks like. This one's an inequality. You're going to graph it almost identical, almost the same way. Take that x minus 2 squared, y minus 5 squared, find the center of that, or the center point from that. So it'd be the opposite. +2, +5 for the center. So I'm counting 1, 2, up. 1, 2, 3, 4, 5. There's my center point. My radius is the square root of 36. And here's another one that's nice. The square root of 36 is 6. Not center, radius. So from here, I'm going to count right 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. So there are my edge points, but don't draw your circle in just yet. If you already did, it's okay, but there's one issue here. This one's not equal to 36. It's less than 36. If there isn't an or equal to sign, so if this was less than or equal to, I'd still draw in the circle. Since it's not or equal to, it's just less than, I'm going to draw my circle, but it's going to be dashed. If you already drew in your circle, just erase the little pieces of it. That's okay. But make this a dashed line. This program doesn't like me drawing little dashes in a circle. It keeps trying to make them straight lines. But you get something close. So there's our boundary. Does everybody understand that it's wanting things less than the radius, less than 36? If I want things less than 36, I'm going to shade inside, things that are smaller than the radius. That means like this. Shading all the way around, something like this. That would be my answer. Any point inside there would work for that inequality. It would make a true statement. Anyone have questions on the front page? Now, this is the majority of what I'm going to be having you do, but I'm going to show you one more piece for that. Math 3 focuses more on how to actually write out the equation. So, example 2, circle is shifted from the origin, 5 units left and 4 units down. 5 units left and 4 units down. Is everybody good with 5 units left being -5 and 4 units down being -4? Right? Left is negative, down is negative. But when I put them in the equation, x minus -5 squared plus y minus -4 squared is supposed to equal the radius squared. And so here, let me use different colors actually. The radius is 2, so 2 squared. Hopefully we're seeing what's happening here. X minus -5 is just going to be x plus 5 squared. Y minus -4, that would be y plus 4 squared. And then 2 squared would be 4. So we have the opposite for each of them. It was down 5, or sorry, it was left 5, but that ends up being x plus 5. It was down 4, but that ends up being y plus 4. Is everybody clear that both the up and down and the left and right values are the opposite of what it looks like every time? Because of the negative in our equation. So now, looking pretty good. Skip example 3 for just a moment. Skip this one. We'll come back to it at the end of class. This part right here is really where Math 3 spends their time. You guys, I'm going to show it to you, but then I'm just going to make sure you guys can actually do the graphic part. But I want you to see this. I want you to ask questions if you have them. The trick is, I need my equation to be in that very specific format for me to be able to tell what the center is. What if they don't write it that way? What if they write something different? What if my x value looks like this? Remember how we factored before? What multiplies to 25 but adds up to -10, class? 5 and 5, right? 5 times 5 makes 25. 5 plus 5 makes 10. How do I actually put that though is it x plus 5 or x minus 5? Is everybody good with them both being negative? Because that way -5 and -5 add up to -10x, and -5 minus 5 would make, or -5 minus 5 makes -10, but -5 times -5 makes positive 25. So this one actually factored into x minus 5 squared, two of the same one. How about the next one? X squared plus 6x plus 9. What multiplies to 9 but adds up to 6? 3 and 3. So this is going to be the same thing. X plus 3 times x plus 3 squared. This ends up being x plus 3 squared because there's two of the same. How about letter C? 7. Right? 7 times 7 is 49. Am I going to want positives or negatives to make that -14? Two negatives. So this is going to be x minus 7 times x minus 7, which makes x minus 7 squared. Are we starting to figure this out, the pattern? Those, all three of them were kind of similar. Yes. So in order for these to add up to 6, we need them both to be positive. So it makes a positive 6 in the middle. All right, let's go over that real fast. But I want everybody to see how this works. If I actually multiply this out, x times x would make x squared. X times 3 would make 3x. 3 times x would make 3x. 3 times 3 would make 9. 3x plus 3x makes that positive 6x that I needed in the middle. Oops, plus 6x. So again, when I multiply it out, I'm wanting this to match what I had here. And so if this one was positive, I need both of these to be positive so that when I add them together, I get that positive 6x. The reason the other ones were negative was because that middle term was negative. So a negative 7x plus another negative 7x would make the negative work. That's what I needed. So what we're just doing here, these are all special trinomials. Specifically, they're known as perfect square trinomials. They make this exact same factor twice. What would that have to be down here? Let's think about this. What number added to itself makes 2? Or what number do I add to itself to make 2? It's like 2 plus 2 makes 4. What plus what makes 1 or 2? There we go. I said it. Yep. But you, David, got it. It's 1. 1 plus 1. So if I were actually to do this, x plus 1 times x plus 1, I multiply this out. X times x is x squared. X times 1, I get a 1x. I get another 1x. Oops, looks like 14, 1x. Those two together make the 2x that they told me in the middle. But I also have this 1 times 1 on the end. I need this end piece to be 1 so that this factors perfectly into that perfect square trinomial. There is a shortcut to this. This format, in order for it to work, take this number and divide it by 2. Class, what's 4 divided by 2? And then what's 2 squared? 2 times 2 is 4. That's the number I need right here. That way, this would be x plus 2 times x plus 2, or x plus 2 squared. How about this one? What's half of negative 6? 3. What's 3 squared? 9. So that's what I'm going to put here. so that this becomes x minus 3 times x minus 3, or x minus 3 squared. Right. The last number is always going to be positive because it ends up being the same thing times itself. And two negatives or two positives both multiply to make a positive. So one more like that. What's half of negative 8? 4. And what's 4 squared? 16. So this would factor into x minus 4 squared. We may come back and talk some more about that in a little bit, but for now, we'll leave it there. As long as you've got this part, we'll do some more with that tomorrow. But for now, let's just go ahead and do the worksheet of graphing. So do the best you can on each of these. For each circle, find the center point, find the radius. So I want you to write them down. So for example, number 1, what I expect to see here, center. This is the homework page. This is what you're all working on for the next 20 minutes or so. Center is -1, 2. -1, 2 is right there. Find the radius. Radius is the square root of 4. Square root of 4 is 2. Up 2. Right 2. Down 2. Left 2. Draw your circle. There's number 1. Excuse me. Thank you. So you guys have what, 12 of those circles? They should be real fast though. Going back up, I'll put it back up there. I was just looking to make sure I knew how many there were. So 12 circles, 11 circles now, 20 minutes. Get as much done as you can. Ask me if you have questions. I'll leave that one up there. I'm going to go ahead and stop the recording at this point.